All right, so worksheet 6 is an introduction to matrices. Matrices actually have a lot of real life uses. One of them has to do with animation. They're used a ton in animation because multiplying by different things transforms all these characters and does all this cool stuff. But for us, we're using some pretty basic stuff today. We're going to think of it more kind of like just a way to organize data. For example, if you owned the McDonald's on 173 and North 2nd, and then you owned a McDonald's in Belvedere, okay? And you had an inventory where you took the buns and the fries, sure. Okay, the buns and the fries, and how many you used Monday, Tuesday, Wednesday at this one, and you did the buns and the fries the Monday, Tuesday, Wednesday at this one, and you could say, I'm just putting really easy numbers in here. So you could say, I could find the total inventory used in both, okay, by adding those together. Does that make sense? Okay, I'm recording, and while it doesn't pick up voices very well, mumbling isn't good, okay? So if you could just be paying attention here, guys. We can add them together as long as the inventory lines up. Does that make sense? As long as buns on Monday is in the upper left-hand corner and buns on Monday used here, we can add up and find out how many total boxes of buns you used at your two stores. Okay? That's when you add a matrix. There's also situations where you might subtract. If this was your old inventory and this was, you know, how many you used, not one makes sense because you have some negative numbers here, but there's reasons you would subtract. There's also reasons you would do what's called multiply by a scalar, which is multiply through by a single number. Okay. For example, if all these boxes cost you $10 a piece and you wanted to know the total cost, you could just multiply everything by 10 that's in there. The other thing that you can do is to multiply two matrices, and that gets more complicated, and I have a really good example of why you would do that later in the slides. But to start out with, what we need to be able to determine is what's called the dimensions of a matrix. The dimensions of a matrix are the number of rows by the number of columns. Now, rows go across and columns go up and down. Everybody okay with that? So if I have this matrix, it is 2 rows by 3 columns. Do you understand that? 2 across and 3 up and down. Okay? So what size is this? Four rows if you were to go across, right? All in one column. Everybody good? Which is rows and which is columns, and you're okay. Yes, you can. I just don't want it to be confused on what I'm writing. So you can write it as an X on yours, and I wouldn't count that wrong at all. All right. You can only add and subtract matrices if they are the same dimensions. Right here at the top I wrote, you can add and subtract. Can only be performed if matrices are of equal dimensions. They're the same size. So these are the same size, yes. What size is that? 1 row across, right? By 2 columns. Both of them are the same, yes? So we can add them together and you will get the same size answer matrix. And you just add row 1, column 1 to row 1, column 1 in the second matrix. So 6 and 3 is 9, and -2 plus 1 is -1. Does that seem easy? Can handle that? All right, this one is a little more complicated. First of all, can you tell me what size these are? 2 by 3. Everybody's okay with that part? And they're both the same size, so we're allowed to subtract them. It is a subtraction problem, so you got to be a little bit careful. But each entry, for example, if I wanted to know what goes right down here in the middle of the bottom row, I'm taking this number and I'm subtracting this number. If that's the only one I cared about, it would be what, -9, guys? -3 minus 6, right? Everybody see what I'm talking about? That you can find any one. If I only wanted to know what's in this top right corner up here and my answer 1, I would do these two, and I'm subtracting, so -4 minus 3 is going to put a -7 up there. I just wanted to show you that you wouldn't have to do the whole thing. Okay, if we're doing the whole thing, -1 minus -6 would become plus +6, so we'd get 5. 2 minus -5 would become plus +5, so we get +7. Bottom row, -4 minus -2 would be -4 plus 2, -2. Everybody okay? Tell me if I make a sign mistake, because it happens. 1 minus 4, -3. Everybody's good? And there's no reason to do them out of order most of the time. I just want to talk about this because when we do multiplication in a second, you have to kind of understand that row 2, column 3 matters, okay? All right. This is just a cute saying. Some teachers teach that one way to remember that it's rows and then columns is by thinking of RC Cola. Does anybody even know they still make that? You know, I like it. It's cheaper than Coke or Pepsi, so. It's just a brand that makes cola, and they make some other stuff too. But all right, guys, this is an icky, disgusting one. Probably not going to be on a quiz because I don't want to grade it. But if all of this is the entry here and this is the entry here and it says minus, first of all, what size is this? 1 row by 3. See the spaces? There's just 2 spaces. It's 1, 2, 3 things. This is all one. You okay? All right, so if I combine these, I'd have 2zx and then what? Minus 2y for my first one here. That's disgusting. All right, and then this middle one was a -3x minus a y plus 5, which would become what? Be careful. Yeah, minus a y and minus the 5. As you're subtracting both of those. That's a z, not a 5. Thank you. I tell you, it's been a long day. All right, and then the last one, this guy minus this guy would be x minus 5z plus 1. Everybody good? What size is the first one on number 4? 2 by 3. Is everybody okay? Make sure you go, I just underline them. There's 2 of those, and then 3 up and down, okay? By, what's this one? Okay. Can you add those? No. It says in the directions, I think you can write undefined. I usually just write no solution, not same size, or not equal dimensions. Whatever you want to write, I'm good. All right. The next part is pretty easy as well. We're going to multiply by a scalar. A scalar, I'll give you an example that's on the final exam in just a second. But a scalar just takes everything in there and multiplies by it. If you do by a scalar in physics, it does kind of the same thing. It makes it 3 times as long. Does anybody do vectors in physics yet? Okay. Anyway, we're going to take all of these and multiply by 3, and our answer is going to be what? We're good? Okay. Let me tell you what's on the test. There's one of these on the final exam, and it looks like this. It says, here's the amount we paid for a bunch of new inventory. Okay, these are 4 items in our inventory. And we are supposed to mark them up 15% and have our pricing matrix. And the question on the quiz says, what are we going to multiply by as a scalar that will give us the new price? It's not 0.15. Because if you mark it by 0.15, they're all going to go down, right? They're not going to be negative, but they're going to be tiny little amounts. That's going to be the markup. So we,
1.15.
yes, we want to charge all of this plus 15% markup, which is 100 plus 15 or 115%. Yes. Yes, 1.0825 will give you the amount of your bill plus the tax added in. Yep, if it's 8.825% tax. All right. Now, if you marked it, if you did 15% and then added it back on, would you get the right answer over here? Yes. But that's not the scalar that I'm looking for. The scalar I'm looking for is 1.15. Now, we can later put this in a matrix and do it, but it's my mind, it's not worth the time. If you just multiply this and round to the nearest penny because it says it's an application, you get stuff like this. 449. Anybody helping me out? Okay. So these are the new prices or whatever. Everybody okay? We will revisit that, but there's a question like that on the quiz and on the final. All right, so that's multiplying by a scalar. If I go back to this number 6, what do you think? I can multiply this by 5. I don't know why I put a comma in there. I don't need that comma. But when I go to subtract this, can I do that? No, these are undefined or whatever you want to write. They're not the same size. Yes. If they're not the same size, you can't add or subtract them. Like this one is a 1 by 2, and this is a 4 by 1. The dimensions have to be exactly the same. That help? Yes. You wouldn't need to, no. You could just say in the end it's undefined. Yep, I don't care. All right. 2 quick weird little questions here. This one is saying this was -3 times something. What did that Y matrix look like before we multiplied by -3? In other words, can we just divide all those by -3? Yeah. We'd get what? Okay. This one, what would we need to do to figure out what matrix B looks like? Yeah, and what size is it going to be? Yeah, same size. So 1 plus something became 5. 0 plus something became -3. And 6 plus something became 7. Or you could have written it over here and subtracted them all, right? Are we okay? I don't think I put one of those on the quiz. I should because it's easy, but. All right. The next thing we're going to do, everybody take a deep breath, stretch your neck. We have to do matrix multiplication. And matrix multiplication, first of all, I'm going to tell you right now, you can do it on your calculator if the matrix is all numbers, okay? I'm going to give you one on a quiz that has a variable in it, so you have to learn to do it by hand. But I'm going to tell you exactly what size it's going to be. But there is a question on the final that says, can you multiply matrix A by matrix B? And this is what it says. To multiply matrix A by B, the number of columns in A must be equal to the number of rows in B. So if you have a 1 by 4 matrix and you want to multiply it by a 4 by 4, that's okay. You can't probably read that, but it says these numbers must match. The number of columns in the first one has to be the number of rows in the second one. Okay? In order to be able to multiply them. Now I'm going to change this. If I make this a 5, I can still multiply these, okay? Because these numbers match. The resulting matrix, though, is determined by the outside numbers. The number of rows comes from here and the number of columns comes from here. If it's the way I have it written right now, this would result in a 1 by 5 answer. Okay, the middle ones have to match and the outside ones tell you the size. This is what we're going to do. Look up here. This is how you multiply matrices. You take this row times the entries in this column. It says you take A times E and B times G, and then you add them together. Does this sound confusing? Okay. And then you're going to do AB times this column. A times F plus B times H to get this guy back here. All right. What we're going to do, yes, row times column. We are going to work on this one a little bit. And I did this last period and it seemed to help a lot. So first of all, what size is A? 1, 2, 3, 4 rows, right? All in 2 columns. Everybody okay? This one is 2 rows by 3 columns. Everybody good? So are we allowed to multiply those? These are the same, so we can multiply. So we're good to go, okay? This, yes. This is going to be the size of our answer, which is going to be 4 by 3. Everybody good? A 4 by 3 would not look like that. Just kidding. There's a 4 by 3. Everybody good? Okay. By the way, I'm going to take a commercial break here. If I switch this around and put this one first in front of that one, is it going to work? Can I do a 2 by 3 by a 4 by 2? Nope, these aren't the same. Matrix multiplication is not, does anybody remember what the word is in math when you can switch the order? Nope. Reciprocal is flipping it over. It's commutative. Commutative property, do you remember ever talking about that commutative property, A times B equals B times A? Well, it does not work for matrices. Do you see that? This doesn't work. Okay, but back to how you actually multiply them. All right. Hang on. So what you're going to do is this row times this column to get the answer that goes in this row, this column. This is row 1, column 1. So it goes in row 1, column 1. Yes, 7 times 7 plus 3 times 8. I'm just going to leave the work because we don't care about the number at this point. You don't even have this. All right, what I want you to do though, rather than trying to go crazy and keep doing this, I want you to go down, I want you to find this one. What row and column is this? Row 3, column 1. That means over here, I am multiplying row 3 by column 1. So it's 6 times 7 plus 8 times 8. How did I get what? Oh, I don't even care what the numbers are. I just want, we're going We're going to do the ones on the worksheet in a minute. Right now, I'm just trying to just see to the pattern, okay? Okay, guys. What if I want this one right down here? This is row 4, column 2, right? So when I go over here, I would be multiplying row 4 by column 2. So I do 9 times 4 plus 0 times 1, which is going to be 36. I can do that one. Got it? Okay. The calculator will do this. It'll do it for you. You get the answer right. As long as you type it in the calculator right, you'll be good to go. What's going to happen is I am going to give you a problem like, on yours, is this a B? Yeah. I'm going to give you one with a variable in it, and you can't do it on your calculator. If you try typing it in on your calculator, there's a value stored in B on your calculator, and it's going to put a number in there. The answer should have a B in it somewhere, okay? All right, I'm going to move back and talk about a couple more things here. I'm going to talk about this matrix application in a second. So this is showing again, row 1 gets multiplied by column 1, then row 1 gets multiplied by column 2. Make sense? All right. And this is just another way of showing it, another way of showing it. All right, we're going to try number 9. What size is the first matrix? 2 by 3. Everybody's okay? And they want to know if we can multiply it by a 3 by 1. Is that allowed? As long as these are the same, yes. And the resulting answer will be a 2 by 1, which means this is going to be 1 column with 2 rows, yes? All right, I'm going to write out the steps so that we can see the work. Does that make sense? Because this is your notes, guys. I don't care on your homework, but on your notes, I would highly suggest you write down how you got this, or you're not going to remember later. We're taking this row, whole thing, times this column to get the first entry. So what am I doing? 0 times -4 plus 2 times 0 plus -4 times 5. I didn't leave myself enough room. All right, this one's a 0 and this one's a 0, so all I end up with is -20. Now I am in the second row of our only column, so I'm going to go back and take the second row and multiply it by our only column. So tell me what I'm multiplying. 4 times -4, -4 times 0, 6 times 5, which is -16 plus 30 or 14 on a good day, maybe? Everybody? Okay. No sleeping. This is tricky. Okay. This is what's on the quiz. One just like this. All right. It is a 2 by 2 times a 2 by 2, so you should be able to multiply it and you should get a 2 by 2. No trickiness there. I'm going to write real big because I want to be able to show how we got each of these. Our answer can be real little, but if you want to show the work as we go, okay. To get row 1, column 1, I am multiplying row 1 by column 1. Does that seem okay? What are the entries in row 1? And over here in column 1? Okay, so I'm multiplying what? 6 times -3 plus -5 times b. What's that going to simplify to? -18 minus 5b? That was glorious. Yeah, it's not going to fit in my little box. Not even close, right? All right. What do you want to do next? I always go across, okay? So we're still in row 1, because that's the way the calculator enters them too. So we're going to stay with row 1, but now we're going to move over to what? Column 2. So we're doing 6 times -6 plus -5 times -5, which would be -36, +25, I'm thinking is -11, anybody? Okay. Now what? I'm in row 2, so I'm using row 2 here, but first I need column 1. So I'm doing 1 times -3 plus 3b, which is -3 plus 3b. And then thankfully we're almost done. What are we switching? We're going to take row 1 over here times column 2 here. So Nick, tell me how I got that. -5, which became -15, right? Okay, perfect. Everybody all right? We good? All right. So number 11, what size is this? Yeah, I literally have to underline the rows because otherwise I'll do it backwards. This is a 3 by 2. This is a 1 by 2. So in the order they're written, can I multiply them? No, actually, if I switch the order, I still wouldn't be able to multiply them, right? All right, what about this fun over here? This is a 3 by 2 times a, this is a 2 by 1. Okay, can we not do this though? I vote we just skip this one. If you want, no, it's not on the test. You know what? Let's do this. Wait a minute. Let's do this. Let's do this just for practice. All right. If you don't want to write it down, don't write it down. But if I could do this one, what size would I end up with? This is a 3 by 2 times a 2 by 1. These are the same, so I can do it, and I would wind up with a 3 by 1, which is going to look like this, yes? Okay. So the first one is row 1 times column 1. I'd have what? -1b plus 4a. The second row, I'm switching down to here and multiplying that by this, which would give me -2b plus 0a, right? Last one, this row times this guy over here would be, all right, just a little more practice. Okay, now you want to know how to do it on the calculator? Okay, this is a real life application, guys. I want you to read this. A furniture restorer refinishes chairs, tables, and dressers. So these are the 3 items that he refinishes. Everybody good? Each step of the process requires a number of hours removing the old finish, sanding it down, and then putting on the new finish. So he's organized this little chart. Does that seem okay? Then he also said, well, this is the cost that he's paying his employees, okay? He's paying them $7 an hour to the guy that scrubs off the old stuff. He's paying $18 an hour to the guy who's sanding it down, because that's a more detailed job, and $10 an hour to the guy who's slapping the final finish on, because if he does a crappy job, he's still going to have to redo it. So a little more than the removing guy. All right, I'm just making up stuff. But this is a 3x3. Everybody good? Okay, so the 3 for the rows were the items. And this was the number of hours doing a bunch of stuff, yes? What is this? This is 3 by 1. This 3 is hours per, yeah, hours per activity, and this is the activities again, right? It's not the items. The items were chair, table. Everybody good? Got me confused for a minute there. And this is the dollars, yes? If we multiply these two match up vaguely, and it will be a 3 by 1 that will tell us what 3 things. Yes, chair, table, dresser, and this will be some kind of total cost. Okay? Yes, dollars. Okay, here we go. We're going to put it in our calculator. Everybody got the calculator? Okay, you're going to want to know this because you're going to use this matrix button to do the whole next quiz. The matrix button is right under the math button, but you have to do second first. Does everybody see it? Second and then the button under math. Okay, so if I go second and the button under math, it's kind of like the list. We're going to edit and enter some stuff first. So you got to scroll over to edit. Scroll over to edit twice. And then you need to pick whichever one you want to put it in. Now, you probably don't have stuff in A, B, and C. It doesn't matter if you do. I'm going to pick to put it in A. So I'm just going to hit enter. I have some old dimensions in here. I'm just going to type over them. What size is my first matrix? 3 by 3. So I'm going to type 3, enter, 3, enter. Now, I got some numbers in here and some zeros. You probably have all zeros. It doesn't matter. We're going to enter over the top of it these numbers. 0.5, enter. 2.5, enter. It goes across as you hit enter. 1, then goes down to the next row. 1, 4, 1.5. And 3, 7, 4.5. Now, double check you have it all in there, right? Real quick. Because if you make any little mistake, it's a hot mess. Everybody good? Because remember, we used every one of those numbers, rows, columns, it's yuck. All right, now you want to quit. That was all it. Quit is second mode. Everybody good to quit out of that? Okay. You don't know how to quit? Second and then mode right next to it. All right. We need to now put in another matrix. So how do we get there again? Second, key under math, which says matrix above it. We're going to go edit. This time I'm going to put it in B, or whatever you want to put it in. And what size is this little guy over here? 3 by 1. So hit enter and type a 3. Enter 1, enter 7, enter 18, enter 10. And then quit. Quit is second mode. You have to quit and go back to the home screen to be able to do this. Now, on the home screen, what I want to tell it to do is matrix A times matrix B. So I'm going to go second matrix button and then just hit enter so that on the home screen I now have an A. Then I'm going to hit times, which really it would understand if you didn't put the times in. Go back and do second matrix button and scroll down to B so that in my home screen it says take A times B. I get that the cost of making a chair is $58.50. The cost of making a table or refinishing a table is $94, and the cost of refinishing a dresser is $192. Yes? No? Did you get those to work? Okay, guys. Dimension mismatch means that you can't multiply those two. You can't do B times A in this case. All right. So do you want to try one more or want to do, we got one more thing to do, right? Determinants? Okay, we're not going to do inverses. We're going to do inverses later, but we're going to just do them on the calculator. By hand, they are a hot mess, and I'm never going to ask you to do one by hand, so just going to do it on the calculator. Okay. A determinant reduces a square matrix into a single number. There's not a great purpose for determinants as long as you have a calculator. So I didn't put this on the quiz, but you're going to think it's really easy and wish I did. All you do is find the product of this diagonal, and you subtract the product of this diagonal, which is 4, I think. Okay, so can you do this one? Okay. Now, the reason I'm not putting it on a quiz, because if I made you do it without a calculator so that I wanted to know you really could do it. Oh, this one had an A? Yeah. Okay, so this one should have been minus 12A. Okay, if it's a 2 by 2, it's easy. I just want to show you this. If it gets bigger than a 2 by 2, what you have to do is rewrite the first 2 columns, and then you do this product plus this product plus this product minus this product minus this product minus this product. Okay? Yeah. It's icky. So we're just going to do it on the calculator. All right. I want you to take out worksheet 7. All right, listen up. Worksheet 7. These are the problems you need to circle. 3, 4, 6, 7, 9, 12, 14, and 18. I think on the original assignment sheet, I assigned one of the inverse problems, but you don't have to do it. Okay, you literally have 5 minutes and 8 pretty easy problems. You can get this done right now.